Hey everyone! What if I told you that the most intimidating letter in all of math, the letter X, wasn't actually a letter to begin with? Welcome to Learn with Ease, the place where we make math make sense. Today, we are unlocking one of algebra's biggest secrets, and trust me, it's a story that's going to change the way you look at your homework forever.
I'm not kidding. The X that's been causing all that trouble in your equations, it started out as just a word. Let that sink in for a minute. This whole thing isn't just about numbers and symbols. It's a journey back in time, an origin story that proves algebra is way more creative and, way more human than you probably think.
So, our story kicks off way back in the golden age of Islamic science, in the amazing city of Baghdad. Picture this brilliant scholar al-Khwarizmi, deep in thought, trying to solve for some unknown value. He needed a name for this mystery number, this thing he was looking for. And he had no idea that his simple choice of words would travel across centuries and land right in your math book.
Check out this timeline. It all started with al-Shay, which just means the thing. Pretty simple, right? But then, fast forward to the 12th century, scholars in Spain are translating these incredible Arabic texts, and they hit a little snag. They didn't have a letter for that sh sound in Spanish. So they improvised. They used the Greek letter chi, which looked like an X, and wrote it as xye. Over time, that just got shortened to X. And there you have it, from a simple word to the absolute rock star of unknown variables. So cool.
Okay, so we know where X came from, but that still leaves the biggest question of all. Why do we have to do all this weird rearranging of equations? Factoring? I totally get it. It can feel like some kind of pointless, frustrating puzzle. But I promise you, there's a brilliant and actually super simple reason behind it all. So stick with me.
And here we have it, the classic quadratic equation. Now, at first glance, it's just a mess, isn't it? It's like someone dumped a box of Legos on the floor. You've got an x squared piece, a few 5x pieces, a little 6 piece. How are you supposed to find the value of x in all that? It's like trying to find one specific brick in a huge pile.
And this is where factoring comes in to save the day. Think of it like this. The equation on the left is a jumbled pile of sticks, but the equation on the right? That's those same sticks just built into a teepee. It's a fragile, linked structure. And here's the secret. If you pull out either one of the main support sticks, in this case the x plus 3 or the x plus 2, the entire thing collapses down to zero. That's the whole point. Factoring turns a messy jumble into a fragile structure that we can easily break apart to find our answer. Okay, real quick before we start building these teepees, let's just make sure we're all speaking the same language. It's easy. The letters are your variables because they can vary, right? The numbers latched onto them are coefficients. Think of them as co-pilots. And the numbers hanging out all by themselves are constants. They're constant. They don't change. Got it? Variables, coefficients, constants. Awesome. Let's do this. All right, first up, we have what I like to call the first key, the grouping method. This is your secret weapon for any expression that has 4 terms. Seriously, if you can master this one technique, you'll have the key to unlock almost any factoring problem that comes your way. This is where you start to feel like a math wizard.
Okay, let's walk through this. First, we just split the expression right down the middle into 2 little teams. Then, for each team, we find the greatest common factor. Basically, what's the biggest thing we can pull out of both terms? For the first team, it's 4x squared. For the second team, it's just a 3. And now, look closely. This is the magic trick. See how both groups now have an x plus 3 in them? That is our golden ticket. We pull that whole x plus 3 out to the front, and whatever is left over, the 4x squared and the plus 3, forms our second group. Boom! It's factored.
I know what you're thinking. That's cool for 4 terms, but my textbook is filled with 3-term problems. Well, my friend, get ready for the aha moment. We are about to use the exact same skill we just learned to crack all of those 3-term codes. It's all about turning a problem you don't know how to solve into one you do.
This right here, this is the master key that unlocks pretty much everything. I'm serious, this one technique will get you through most of the factoring problems you will ever face in high school. So let's walk through it together. So here's our mission. Should you choose to accept it, we have a trinomial, 3 terms. Our goal is to strategically split that middle term, the 7x, into 2 new terms. Why? Because that will give us a 4-term expression, and we already know exactly what to do with that. Okay, here's the secret sauce. It's all about finding 2 magic numbers. First, we multiply our a and c terms. So that's the 1 from x squared and the 10. That gives us 10. Now here's the puzzle.
We need two numbers that multiply to 10 but add up to our middle number, 7. Think about it. What could they be? Yep, 2 and 5. So we rewrite our 7x as 2x plus 5x. And just like that, we're back in familiar territory with 4 terms. We do our grouping magic from before, and voila, our teepee is built.
We didn't. We built our teepee. All the hard work was basically just drawing the treasure map. Now it's time for the payoff. Let's follow the map to the X that marks the spot.
So just think about this for a second. We have one thing, x plus 5, times another thing, x plus 2, and the answer is 0. What does that tell you? Well, it means one of those things has to be 0. It's literally the only way to multiply two numbers and get 0 as the answer. And that simple idea is the key that unlocks the whole thing.
This leaves us with two very, very simple possibilities. Possibility 1, the first part, x plus 5, is the part that equals 0. Or possibility 2, the second part, x plus 2, equals 0. All of a sudden, that one complicated quadratic equation has become two super simple problems.
And solving those is a piece of cake. It gives us our two solutions, x equals -5 and x equals -2. These are the hidden values. These are the answers to the puzzle. This is the value of the thing that Al-Khwarizmi was searching for nearly 1,200 years ago.
How awesome is that?
And there you have it. From ancient Baghdad all the way to your notebook, X has always been about solving real problems. The exact same logic you just learned is used to design bridges, to predict stock markets, and even to create the video games you love. So the next time you see X, don't just see a letter. See a challenge, see a puzzle, see a tool for building the future. The real question is, what are you going to build with it?
I really hope this journey into the world of X helped you see algebra in a totally new light. If it did, show some love with a like, a comment, or a share. And definitely don't forget to subscribe to Learn with Ease for more math adventures just like this one. Thanks for watching, and keep on solving.